Alright, so what is PWM? Pulse Width Modulation. Many people have heard the name, a very few of them actually know what it means. In this video, we are going to take a look into what pulse width modulation is and how you can use pulse width modulation in your practical electronics and any accessories where you want to actually vary the output power that is being delivered. So what is PWM? Coming right up. So pulse width modulation is actually a technique through which you control the average power that is being delivered to your output devices. What can these output devices be? Maybe they are just LEDs, maybe you want to control motors for some reason. For example, if you want to create a robot which is actually has wheels, then pulse width modulation can be an incredible technique through which you will control its speed, motor's speed as well as the robot's speed. You may also use pulse width modulation to modulate the series lighting that you have in your house which you use for decorations. The requirements and the demands are endless. The practical applications of pulse width modulations is endless. Now, what actually is it and how is it done? Before we go ahead and understand what is pulse width modulation in its entirety, it is very important for us to understand what are the different ways through which you can actually control power that is being delivered to the output devices or the load devices. Well, the first way it is done and it is most widely used, and this one method is being taught to almost every electronic engineer when the task of dividing voltage is concerned, and the method is using a potentiometer. What is potentiometer? Potentiometer is nothing but a variable resistor. When I say variable resistor, it's just a resistor whose resistance can be varied with the help of a knob. So what happens is when you provide power supply to a circuit that has a variable resistor and a load connected to it, so whenever you are going to change the knob of the resistor, some power of the source is going to be dissipated in the resistor, in the variable resistor, and the rest of the power will then be delivered to the load that is under consideration. Now, you know what? Let me bring up Master G and I'll show it how it actually happens in the most practical sense. So just give me a second, alright?
A few moments later.
Right, so we have Master G in the house, and in this board I am going to tell you how actually voltage gets divided when we are using a potentiometer and how the remaining voltage will then be going on to the output load devices which is under consideration. Can be LED, motors, you tell me, whatever, right? Before that I have to clean this up. So here is what is happening, alright? So first, let's say this is our voltage source which actually provides the power that is being delivered to our, let's call this L, alright? L means load. This can be anything, maybe it's a motor or an LED or a series or a power LED, whatever, but you get the point, right? So we have our source and we have our load. If I just connect this point to this point, the power that will be generated by the load will be of a constant sense. There won't be any kind of variation that you will be able to provide to your load. So no speed variation, no intensity variation, anything. But what happens if we provide a variable or L, let's call it variable resistor here, which is also called as potentiometer. So when you vary this, some part of this source is going to be dissipated here. I am very carefully using the word dissipated because this will become the stepping stone to why PWM is actually used. Now, the amount of power which will not be dissipated here will then be provided to this load, and its intensity will depend upon what is the kind of power that is being provided to the load when the when some amount of that power is dissipated in the load resistor. Alright, so this is how a basic electronic circuit that is to be used for wheeling power into the load devices is being created. Now let's take it off.
Let's take master off and let me take my position.
So that is one way as to how you can control the power that is being delivered to the output devices. Can there be another way? Why not? Just connect your LED directly to your lab test power bench and control the voltage from the power bench itself. But what are the problems with these two methods? Not very applicable to real-time applications now, is it? Let's say you are creating an embedded system. Let's say you are creating an electronic circuit that has to do one and only one task. Now, let's say you are creating an electronic circuit which has to do just one and only one task. You are not thinking of sitting there and controlling the power manually, are you? Or you are not sitting there and rotating the knob of your potentiometer as per the need is required. No. When you are actually creating a circuit where you continuously want some kind of power delivery, some kind of power manipulation to happen, some kind of voltage manipulation to happen, that is where PWM comes in. So pulse width modulation is modulating the pulse with the help of a switch for a certain amount of time so that the output power to the load can be controlled. I know you don't understand any of this. It's fine. It's absolutely fine. Let's say there is a power source with you that delivers a 5 volt continuously, right? Now, in pulse width modulation, what happens is I create a switching mechanism such that the power is not delivered for the whole time period, which is determined by the switching frequency, but for only a certain amount of time. The percentage of this time for which the complete power from the source is going to be applied is called duty cycle. Let me make it simple for it. For example, let's say I have set the switching frequency such that only for half the time the switch is going to allow 5 volts to be provided to the output source. In this case, what is going to be the duty cycle? 50%, isn't it? Because the switch allowed the power supply to go through for only 50% of the time. Let's say I allowed the switch to be open for 3/4 of the time period. Then what is going to be the duty cycle in this case? 75%. See, it's so simple. You are now getting it. Now you might be thinking, alright Rajput, that's fine. But the switch is going to remain open for let's say 50% of the time. And for the rest amount of time, the switch is not going to allow the power to go through the load. Then will the LED not produce a flickering effect? That's an incredible question, my friend. But the time aspect when it comes to electronics world is far different than how we perceive time. In electronics world, everything happens really quick. With reference to the speed at which this switching frequency happens, the only thing that will be visible to your eye will be an average deduction in the power that is being delivered to the load. That is why you don't see any flickering when you are using pulse width modulation to control any kind of devices. Now that we have understood what is pulse width modulation, let's understand how this is superior to the other methods that we just discussed. In the method in which we deployed a potentiometer, what is happening is there is some loss of power that is happening. There is no sustainable use of energy, if you don't mind me using that word. Well, sustainable is a general word that can be used in a variety of different ways, but here also we can use that word safely. The thing that we need to understand here is that there is dissipation of power. And is there a way where we can actually create a circuitry where this power dissipation doesn't happen? What will be the case when it comes to the left test bench power supply that we talked about? Well, it's simple, it's not effective, it's not applicable in real time. So, how pulse width modulation circuitry is superior than these methods is because here we are modulating power at the source, right? So, no power is being dissipated anywhere. How much power you need, that much power is being applied and that much intensity from the load is being then extracted. So, in that way, it's a very energy efficient mechanism. Now, we know how effective PWM is with the traditional methods. It's also very important to know how do you actually create this signal. Can we make the circuitry by ourselves? Well, of course you can, my friend. And because of that, I have left the circuit diagram of two ways of creating pulse width modulation onto my website. I am going to flash the screen here, and I'll also leave the link to the blog post that I created on my blog along with this video, so that you can just go ahead and check it out. There are two ways that I've described how you can create pulse width modulation signal. One of them uses the grandfather of all ICs 555 timer, and the other method that I've described uses Arduino. So people who are a little advanced in electronics and know what embedded systems are and know what Arduinos are, what microcontrollers are, can use that method, which is very effective also. Or if that is not the case, and if you are a beginner, I would suggest you to go ahead and make a circuit using a 555 timer, and it is very simple. And for some reason, if you are stuck somewhere, you can always ask me in the comments section, and if on some day I am feeling a little wild, I will actually create a video describing step by step how to do the same thing. Now that we have understood what PWM is, now that we have understood how superior it is to the other methods, what is left is one very simple question. Alright Rajput, when it comes to 5-volt devices like LEDs or like low power motors, that's fine. But what if we want to control high power devices such as high power LEDs, series lighting and high power motors? Can we use PWM in that case also? Well, if you can't use that, all of this in that case also, what good is it? You can definitely use it, but you need another little device that is, it's not little, another incredible device which is called MOSFET, right? So how do you connect the MOSFET to the device you want to modulate power on? This is also something that I've taken care of on my website. When I've created the circuit diagram, I have added how you are going to connect your MOSFET to your load device and to the PWM circuitry again in the website itself, so you can just go ahead and check how it is done. But just for the info, let me just chart it out in front of you as to how does it happen. The gate side of the MOSFET gets connected to our PWM signal. The negative side of our LED is going to be connected to the drain of the MOSFET, and the source is going to be common with every ground that we are going to be using with our electronic circuit. I know this is a little bit technical, I know. This is the precise reason my blog post is there, so that you can just go ahead and see everything step by step how things are being done. So with this video, I wanted to make your feet wet with some basic aspects of electronics. Don't worry, there are many such videos that are coming out in which I am going to explain various different basic aspects of electronics. Once we are done with the basics, then we'll go to intermediate, and then we'll do some advanced things. That was stupid. But anyways, so I hope you enjoyed the video. I hope you understood what is PWM, how it is used in practical electronics, how to create one, and how it is superior with every other technique that is we have discussed right now, and those techniques which are also being used all around practical electronics to control power. If there is any doubt whatsoever, I want you to comment it in the comment section below, or if you want to have your queries answered instantly, almost instantly, you can also go ahead and comment the same thing in the PWM blog post in my blog, or you have any other kinds of requests that you have, or you want me to create a video on any special electronics topic, you are welcome to comment that also. And with that said, I take my leave, and I will see you in the next one. Namaskaram.